Follow along to see how VFI silicone is great for 3D printing and part-making projects. We chose a simple yet detailed 3D print mold of a dog to make a silicone mold. This 3D print came in 2 parts, which we assembled to hold the silicone once poured. The exterior shell also comes in handy when casting into the silicone mold. To ensure that the silicone would not leak out of the 3D printed mold, we clamped each side. We start by measuring out the A and B components of our chosen material, SHARPCAST VFI-1540 Platinum Silicone. It has a 10A to 1B mix ratio by weight. This is a thick material, so you'll have to thoroughly mix for at least 3 minutes to ensure the mix is uniform. Scrape both the sides and bottom of the container while mixing. To dissipate any trapped air in the mix, we degassed the material. Due to the amount we mixed, we put the material in separate cups to create headspace and placed them in a bucket in the vacuum chamber to avoid overflow. Degassing took around 20 to 25 minutes due to the size of our cups, but it can be done faster with more headspace. Due to its thickness, we tried to pour the silicone in a thin stream to allow any remaining trapped air to dissipate. This also allowed it to flow into all the crevices within the mold. We gently tapped the mold on the table to help the silicone flow into any hard-to-reach areas. We then added the remaining silicone to top off the mold and make it level. The next day, we were able to demold. We first removed the clamps from the 3D printed shell. To break open the shell, we used a screwdriver as leverage. This allowed us to separate the pieces easier. Silicone will demold from 3D printed materials like PLA without the need for a release agent, so we did not use one for this project. In order to break the seal created by the cured silicone, we used a popsicle stick to separate the 3D part from the rubber. This took some time, since there were various curves and undercuts to this piece. Once completely demolded, we decided to cast one of our fast urethane plastics, VFI-4171, to make the finished part. We first reassembled the 3D printed shell around the silicone mold for support and stability. To assist us with demolding, we cut a small slit down the side of the silicone mold, so we clamped the supported shell again to ensure the urethane would not leak through. For the urethane, the mix ratio is 100A to 87.13B by weight, so we first measured out the A side. This material has a short pot life, so rather than degassing the complete mixture, we only degassed the A side to remove any trapped air. Once we were done degassing, we added the B side to the A side. This material has a 5-minute pot life, so you must mix quickly and pour before it starts to gel. We ensure a uniform mix by scraping the sides of the cup as we mix. Then, we pour the mixture into a clean cup and use a clean stick to mix again. This ensures there will not be any uncured material throughout the mixture. After mixing, we poured the material in a thin stream to allow any remaining trapped air to release. We topped off the mold to ensure the part would have a flat base. After a few minutes, the material will flash, alerting you that it is heating up and curing. It will take around 40 minutes to cure before it can be demolded. To begin the demolding process, we removed all the clamps from the 3D printed outer shell. Then, we removed the 3D printed shell to get to the silicone mold. Being careful not to tear the silicone mold, we gently worked it away from the undercuts and other details. The pre-cut area on the mold was useful to help us work the urethane part out of the mold more easily. Here you can see the amount of detail that the urethane was able to pick up from the silicone mold. All that detail was transferred over from the 3D printed part. Thank you for watching, and visit volatilefree.com for more info.